Today we are looking at lesson 8.1, and we are going to be graphing f of x equals ax squared. Now, before we get into this new type of graphing, I want to review the two types of graphs that we have done so far. But you've got to go back before chapter 7, all right? You've got to go back because chapter 7 was all about foiling and factoring and polynomials. So the information that I'm looking for today was before chapter 7. We've graphed two different types of graphs so far this year, all right? The first and most basic is a linear function. What does a linear function look like if we graph it on a coordinate plane? A line. It's in the name, right? Linear is a line. Now, the second type you learned, and we learned it in chapter 6, all right, where we learned all about exponents, was an exponential function. Does anybody remember what an exponential function looked like? What was the shape of an exponential function? It had a banana shape, right? It was kind of curved and it kind of looked like a banana. Well, today you're going to learn about a quadratic function. And the first thing I want you to see in the essential question, it says, what are some of the characteristics of the graph of the quadratic function? So let's go ahead and highlight quadratic function of the form f of x equals ax squared. Now, here's how you know it's quadratic just by looking at the problem. There is going to be an x squared term. So I want you to highlight in the little formula it gives you in the essential question, I want you to highlight the x squared. Because up to this point, what we've been graphing has not had an x squared term. And this is how you're going to be able to identify quickly a quadratic function. Now, look at the shape of a quadratic function. Every quadratic function has a U-shaped graph called a parabola. So now not only does it have a shape, but it also has a name. All right, a U-shaped graph called a parabola. Now, I've given you two examples of a parabola, and if you can see them on your paper, there are two different ways in which this parabola opens. All right, I'm just trying to highlight this, make it a little bit darker. We've got this first one that I've given you, and we've got this second one that I've given you. Okay, what direction would you say that this first one opens up? If I were to ask you how that parabola opens, would you tell me it opens up, or would you tell me it opens down? It opens up, right? It's opening up, okay? And what would you tell me about this one? Is it opening up or opening down? It opens down, all right? So that leads us into the different characteristics of a quadratic function. There's four things that we are going to focus on today. Number one is the vertex. So I want you to take and highlight the vertex. And let's look at the definition. It says the highest or lowest point on a graph. So I want you to highlight the word point. The vertex is a point. And guys, when we identify a point, what does a point look like on paper? It's written. How's it written? An ordered pair. So somewhere above or below the word point, this is what I would add into your notes. I would add an ordered pair. So a vertex is always going to be an ordered pair. Now you notice it says the highest or the lowest. Guess what it depends on? It depends on what direction your graph is opening. If my graph is opening up, there's a low point, right? There's a low point on that graph. If my graph opens down, you can look right back at the picture we just talked about. If my graph opens down, then there is a high point to that graph. So it's the point, either the low point or the high point, but it's a point. The second thing you need to be able to see and recognize is the axis of symmetry. So I want you to go ahead and highlight axis of symmetry. Now, this is a line that passes through the vertex that divides the parabola into two symmetric parts. Now listen, you know symmetry. I'm pretty sure, I think my kindergartners right now are coming home with papers where they've drawn a line and split something into two equal halves. Okay, so that's what this axis of symmetry is going to do. But focus on the word line, and I want you to highlight, it's a line. All right, and I've given you a picture, and you can see in the picture in your notes, they have used a dotted line to show that axis of symmetry, and that's exactly what we're going to do. When we graph here in a couple minutes, we're going to draw the axis of symmetry, and we're going to use a dotted line to do it. Okay, so the axis of symmetry. Now, I want you to look at that dotted line in the picture. All right, if you're not sure where I'm at, I'm going to, right here in the graph that I've given you, this is the dotted line that I'm talking about. What type of a line are we looking at? And don't tell me straight, because I know it's straight. It's a vertical line, right? And we've done this, if we were to write the equation of a vertical line, what variable is in our equation? What axis does a vertical line pass through? X. So when we write the equation of a vertical line, what variable is in that equation? X. All right? So again, above or below the word line, I want you to write X equals question mark. Because when we are asked and when we identify the axis of symmetry, when we label the axis of symmetry in a graph, we're always going to put X equals and then whatever value our line crosses through on the x-axis. Okay? The third thing you should be familiar with is the domain, and you'll see the domain of these parabolas is going to be all real numbers. If you look again at the picture, there's arrows on either end. All right? That means that my graph goes off in both directions forever and ever to infinity. So there's nothing that x cannot be. So my domain is going to be all real numbers. And last but not least, we have the range. Which set of values does the range deal with? Y. And you can see very easily and very quickly, we're either going to have y is greater than or equal to a number, or y is less than or equal to a number. Now let me help you make this a little bit easier. All right, look at the picture that I've given you. That graph opens what direction? Up or down? It's opening up, right? So let's think about what makes sense. Do you think the y value we choose is going to be greater than or equal to or less than or equal to if my graph is opening up? Greater than. Doesn't that make sense? If the graph opens up, then my range is going to be y is greater than or equal to some value. So in my notes, I would add right here, opens up. Now, if that doesn't make sense to you, you can use whatever words you want. But basically what we're saying, when the parabola opens up, we're using y is greater than or equal to. Now, what does that mean? When would we use y is less than or equal to? When it opens down. Remember, when the graph opens down, it has a high point. So once we find the highest y value, all the other ones are going to be below it. So I would add the note here, okay, when our graph opens down. We're going to use y is less than or equal to when our graph opens down. Okay? Now, let's look at a given graph and let's identify these characteristics. Again, what were the 4 characteristics that we just listed? All right, the vertex. We're going to go ahead and list these characteristics underneath the graph so we know what we're going to identify. We've got the vertex. What's the second characteristic we talked about? The axis of symmetry. So we're going to write axis of, and if you want to abbreviate symmetry, I'm okay with that. What was the third characteristic we talked about? Domain. And what was the fourth? So these are the 4 pieces of information we're going to identify right now. Now, find, first off, does my graph open up or down? Because that's going to help me find the highest point or the lowest point, which is my, what? No, the highest point or the lowest point is my vertex, okay? So what would be the vertex of letter A? I heard -3, 7. So let's see. If we start in the center right here and we go left to -3 and we go up to 7, we absolutely are at the highest point on this graph. So we're going to plot it, and let's go ahead to the side of it and let's go ahead and label it. It was -3, 7. Now we're also going to list it underneath down here. So the vertex is the ordered pair -3, 7. All right, the axis of symmetry. Remember, it's a line that goes through the vertex and splits the graph into 2 equal parts. So we're going to use a dotted line, but we're going to start at the top of our graph and we're going to draw a dotted line. It's going right through the vertex and it's going all the way down to the bottom of our graph. All right, now it's a line, so we're going to put a little arrow on each end. But what is the axis of symmetry? Where does this line cross the x-axis? -3. So what do I write down for the axis of symmetry? Not just a number, it's a line. We need the equation of the line. So what is it? X equals -3. Remember, we added that to our notes. It's a line. So when we identify the axis of symmetry, we have to write the equation of that line. So x equals -3. Now, the domain, if you look at each end of the graph, there are arrows. So what does that make the domain of this parabola? All real numbers. Good. And what variable are we using for range? Y. Now we got to decide greater than or equal to or less than or equal to. This parabola opens down, so what did we decide that means about our symbol? Less than or equal to. So the only thing left to do is pick The y value. So what is the highest y value? Why highest? Because our graph opens down. What is the highest y value on this graph? 7. Now, I want you to look a little closer at this. I want you to go back to the vertex. And I want you to go to the axis of symmetry. What do you notice that the vertex and the axis of symmetry have in common? They have the same x value. And guess what? That's going to be the case every single time. Whatever your vertex is, the x coordinate of your vertex is also going to be your axis of symmetry. Okay, now look at vertex and look at range. What do you notice about the vertex and the range? The y coordinates are the same, and that's going to be the case every time. Whatever y coordinate is in your vertex is also the value that should be going in your range. All right, for letter B, we're going to identify the same 4 characteristics. So we're going to identify the vertex, the axis of symmetry, the domain, and the range. All right, who found the vertex? Somebody give me the order pair. Elijah?
2, -.
All right, if I go right to 2 and down to -3, I definitely have the vertex. All right, so I'm going to label it on the graph, and I'm going to drop it down underneath the graph. So 2, -3. Now, the axis of symmetry. The axis of symmetry passes through the vertex, so it also passes through what on the x-axis? 2. All right, so we're drawing a dotted line through the vertex from top to bottom, and that makes our axis of symmetry equal what? 2. So 2 is the number that I'm going to write down next to axis of symmetry, correct? No. What do I have to write down when I find and identify? Good. I have to write an equation. So x equals 2. All right, what's the domain? All real numbers. Again, this parabola had arrows on both ends, so this is an all real numbers domain. There's nothing that x cannot be. And the range. What variable goes in our range? Y. Is it greater than or equal to or less than or equal to this time? Y greater than or equal to? The parabola opens up. So once we find that low point, everything else is above it. And what is the y value for the range? -3. Again, notice the x coordinate of the vertex and the axis of symmetry match. The y coordinate of the vertex and the value of the range also match. Go ahead and box these in. I know I forgot to on the first one, but go ahead and box both of these in as your final answer. Now, when we move to example 2, it simply says graph the function. So at this point, I want you to get your phones out. I want you to open either your Desmos app, or I want you to go through the internet on your phone to desmos.com. But before we start plugging things into Desmos, there's a couple of things I want to add to our notes, and I want you to remember. We've got g of x and we've got q of x in these two problems. What variable are we able to replace g of x and q of x with when we plug these into Desmos? Y, all right? So if you have forgotten that, I would go ahead and do that first. Okay, just show yourself that you can cross out the function form and you can replace it with a y. Now, I also want to make sure you know exactly what I'm looking for, because this is a new type of graph. So I want to make sure you know exactly what I'm looking for when you graph these. Look, Desmos does most of the work for you. There really is a lot of work that would go into graphing this by hand. So I'm very particular about what I want to see on the graph. All right, so I want to make sure you know what I'm looking for. Based on what you understand of a parabola to look like at this point, what do you think is the most obvious point that I want you to graph? The vertex, all right? So either beside the directions in your notes or under them, let's just kind of list the things I'm looking for. I definitely want you to graph the vertex, all right? What else do you think I want to see when you graph this? The axis of symmetry, very good. Okay, and not only do I want to see it, but I also want you to label it. So if you need to make yourself that note, you're going to draw it. It's going to be a dotted line, and you're going to label it with x equals whatever. All right, then how many more points do you think I'm interested in? We've already got the vertex. So you know me, how many points do I usually like total? 3. So here's where you're going to get those next 2 points. Okay, I want 1 point on each side of the axis of symmetry. Okay? I want 1 point on each side of the axis of symmetry. And you can write it out or you can abbreviate it like I'm doing, but I just want to make sure you understand we're going to do 3 points total. We want the vertex, I want the axis of symmetry, the line, I want it labeled, and I want 1 more point on each side of the axis of symmetry. Now, I want you to take your Desmos, I want you to take question A, and I want you to plug it in. Now, the keyboard button, when we hit it, we have all the letters and numbers that we need. So it was y equals, what did you plug in? Y equals 5x. And remember, you can hit that little a squared button, and it will square the variable for you. Now, we always want to zoom in and out until we're looking at at some exact points. But very easily, you can identify the vertex, right? What is the vertex here? 0, okay? So remember, you can... if you want to put that into Desmos, you can. When you hit the enter button, it'll give you a new line and you're able to plug in whatever you want. But here we have 0, 0. All right, so we got 0, comma, 0. All right, remember you can tell it to label if you want to get everything on Desmos before you transfer it to your paper. Okay, the next thing I want to see, what was the second thing we wanted to see on this graph? The axis of symmetry. So when you draw the axis of symmetry and it goes through the vertex, what point does it cross on the x-axis? It does. So what is the equation then of the line this time? X equals 0. Good. So we do x equals 0. And remember, if we hit the setting button here, we're able to make this a dashed line. So we can put it on here if we want. But you're going to put it on your paper. Start at the top of your graph, draw that dotted line all the way to the bottom, and then I want you to label it, all right? What are we labeling it? We're labeling it with the equation. So either at the top or the bottom, it does not matter to me. You're going to just write x equals 0, all right? X equals 0. Now, we need 2 more points. What were 2 more points on this line? All right, say it one more time. All right, 1, 5, and we're going to label it. All right, very good. And what is another point on this line? Good. Do you see how they mirror each other? That's the good thing about this axis of symmetry. It splits it into 2 equal parts. So finding the points, once you find 1 point, you should very quickly be able to find the other point. So I believe the other point you guys said, help me out one more time. -1, 5. And if we label it, absolutely. So now we transfer all of that onto our paper. Again, we're going to put what on either end of the parabola? Don't forget your arrows. And remember, either at the top of your axis of symmetry line or the bottom, just to the right or the left of it, just label it. X equals, in this case, x equals 0. All right, we've changed q of x to y again. So what's the equation for letter B? Y equals? Okay, -0.1 x squared. Is that correct? All right, again, you want to zoom in or zoom out until you can see exact points. All right, you've got the plus and minus on the sides. All right, what's the first thing that I want you to graph? The vertex. What is the vertex of this graph?
0, 0.
Good. We got 0, 0, and we're going to label it. All right. What's the second thing I want you to graph?
Axis of symmetry.
The axis of symmetry. Avery, what's the axis of symmetry this time? X equals 0. All right. Again, we draw the axis of symmetry through the vertex. We do it as a dotted line. And then we label it over to the side, okay? But top to bottom, make it go to from the top of your graph to the bottom of your graph. All right? Now, we need 2 more points. What's the next point that you see? And we want exact points, so what do you see? All right, let's try 10, -10. Label it. There it is. Good. And what would be 1 more point on this graph? All right, let's see, -10, comma, negative 10. Keeps doing 11 for me. I'm not sure why. There it is, an exact point. So we plot our points, we label them, we draw that axis of symmetry. Don't forget, either at the top or the bottom, we label it with the little equation, so x equals 0. And of course, our parabola has arrows on the end. Now we move on to example number 3. It says, compare the following equations to the equation of f of x equals x squared. And you see right here where it says, grab your cheat sheets. So go ahead and grab your cheat sheets. If you have not been able to find your cheat sheet, all right, you need to grab a friend, take your cheat sheet down to Miss Rockefeller, and she will make you a copy, okay? Because I don't have any extra copies. I told you guys to hold on to these, that we were going to use them again. You've written so many things in on them. So hopefully you still have them, or you can find a friend that will let you make a copy, okay? But before we move any further, let's talk about f of x equals x squared. Does anybody remember what we called this? F of x equals x squared. This is where every single graph would start, and then we would transform it. We would move it up, down, right, left. We would reflect it, or we would stretch it or shrink it. Does anybody remember what this first formula is called? No? Okay. Remember, we called it the parent function. The parent function. Because remember, before we can figure out the transformations, we have to be able to find and identify the parent function each time. So x squared is the parent function. Something is going to be done to this parent function, and that's what we're trying to figure out. So when we see the word compare, remember this, or these are cheat sheet problems. These are transformation problems. So look at letter A, and we're going to move through these pretty quick, only because this is supposed to be kind of a refresher. We've done this before, so hopefully it starts coming back to you. But if you look at letter A, I want you to find and highlight the parent function. Remember, x squared is the parent function. So we should be able to see very quickly how many transformations have been done to this parent function. Anybody remember? Somebody guess. How many things have been done to x squared? I'm not asking for specifically what's been done, but how many things have been added to this equation? 2. Remember, a sign change is its own transformation. A multiplying of 3 is another transformation. So 2 things have been done to this parent function. And we're going to list 1 and we're going to list 2. Okay? Now, sign change. Look at your cheat sheet. Which type of transformation deals with a sign change? A reflection. So this is a reflection. Now we got to decide. This is where people tend to get confused. Have they changed the sign of the f of x, which is the whole function, or have they changed the sign of just x? Okay, but remember, if it's just x, they're going to be in a set of parentheses with the x. Do you see parentheses in this problem? No. So they have actually made the sign change to f of x, which is also what variable? We can change f of x to be a y. Okay, so this is a, look at your cheat sheet. If they have changed the sign of f of x or y, this is a reflection across which axis? The x-axis. Remember, it's the opposite. So they changed f of x or y, so it's a reflection across the x-axis. Now, we're done with the negative sign. Now we're focused on the 3. Are they adding, subtracting, or multiplying that 3? So what type of function or transformation deals with multiplication? A stretch or a shrink. All right, good. So what are they multiplying 3 by? The f of x or just x? Again, just x, they would be in parentheses with just x. I mean, look at your cheat sheet. Do you see how they have ax inside parentheses? All right, there is no parentheses in this problem, so they are not doing anything to just x. They're doing it to the entire function, the f of x. So is that vertical or horizontal if they're multiplying by f of x? That is vertical. Okay, now we take the number they're multiplying with and we plug it into one of those little equations. Is 3 greater than 1, or does 3 fall between 0 and 1? It's greater. So is that a stretch or a shrink? That is a stretch. So it's a vertical stretch by a factor of what? 3. Remember, we like vertical because it's exactly the number that we see. So it's a vertical stretch by a factor of 3. Did anyone feel like saying by a factor of -3? All right, but remember, the negative sign is its own transformation. So we're not looking at a -3. We are simply looking at a 3. All right, so these are your two transformations. Like I said, hopefully it's coming back to you. All right, look at letter B. Find and highlight the parent function. Do you see the parent function right there? So how many things have been done to this parent function? Just one. All right, so we have one transformation. Now, what are they doing? Are they adding, subtracting, changing the sign, or multiplying here? They're multiplying. So that takes us down to what type of transformations? Stretches and shrinks, okay? What are they multiplying by? F of x or just x? Again, you see no parentheses, right? They're not in parentheses doing something to just x. So if they are multiplying by f of x, this is vertical or horizontal? This is vertical. It's a vertical. Now, 1/3, plug it into those little formulas again. Greater than 1 or falls between 0 and 1? It's a fraction, right? It's a fraction that does not turn into a mixed number. So it is definitely between 0 and 1, which makes this a vertical what? Shrink. This one's a shrink. Again, by a factor of what? By a factor of 1/3. Awesome. And we'll box it in. Now, be careful when you see one like letter C. Remember, f of x equals x squared. This is the parent function. That's where the problem started. We are focusing on the h of x equation. All right? Again, let's find and identify the parent function. We see it right here, right? There's an x squared in that new function. How many things have been done to this parent function? 2. Again, remember, the sign is its own transformation. So we've got 1, 2 that we're going to list. All right, sign change. What type of transformation is a sign change? A reflection. So we can go ahead and write reflection, but we got to decide a reflection across what? All right, again, they're changing the sign of the entire f of x function. They're not in parentheses doing anything to just x. So this is a reflection across the x-axis. Awesome. All right, what about the 1/3? Does this look familiar to anyone? We just did 1/3, right, up there in letter B. So nothing has changed. This is still vertical because they're multiplying by the entire f of x function. 1/3 still falls between 0 and 1, so it's still a shrink. And the factor has not changed, so it's by a factor of 1/3. And we box in the two transformations. Now flip to the next page in your notes to lesson 8.2. I want you to notice the title of this lesson. It says graphing f of x equals ax squared. All of that was in the title of 8.1. But now what have they added to the title here? Plus c. So guys, what transformation has you adding or subtracting something to the problem? Transformations, right? Or translations. I'm sorry. They're all transformations. The translation. So we're carrying example 3 right into lesson 8.2. Essential question, how does the value of c affect the graph of f of x equals ax squared plus c? So we're continuing to look at transformations. Letter D, again, find and identify the parent function. What is the parent function? Everybody. X squared. So find and highlight the x squared. Now, how many things have been done to this function? Be very careful. If you read that, all right, if you read that problem, it says g of x equals x squared minus 5. So how many things have been done to this function? You've minus to 5. That's it. All right, so there is one transformation here. Now, if you add or subtract to a function, what type of transformation what do you have? A translation. But first, are we subtracting 5 from the entire function or from just x? Again, there's no parentheses. Remember, if they were doing it to just x, they would be in the parentheses with just x. They're outside. There are no parentheses. So they are subtracting 5 from the entire function. So vertical or horizontal? Vertical. So we know it's a vertical translation. The only question is what direction and how many units? Well, it's -5. Again, we like vertical because vertical, when something is vertical, it's what we see. So if we're subtracting 5, and this is a vertical translation, what direction are we moving? Down. On the vertical axis, on the y-axis, down is a negative direction. So we're moving down how many units? 5. It's right there in the problem. So this is a vertical translation, down 5 units. The parent function in letter E. There's that x squared again. How many things have been done to this function then? 3. You have a sign change, you have a 1/4, and you have a +4. All right, so let's start with the sign change. We're just going to work our way left to right. A sign change is what type of transformation? A reflection. Good. Reflection. Question. Are they changing the sign of the entire function or just x? Entire. Good. So it's a reflection across which axis? Good. Across the x-axis. All right. Next we have 1/4. What are they doing with 1/4? They're multiplying. So that takes us down to stretches and shrinks. Okay. Are they multiplying, Talon, by the entire function or just x? Entire function. So is that vertical or horizontal? Look at your cheat sheet. If they're multiplying by f of x, which is the whole function, is that vertical or horizontal? That is vertical. Good. Now, plug that 1/4 into those little formulas, and it's a vertical what? Anybody? Shrink. Remember, 1/4 falls between 0 and 1, which is a shrink. And again, it's vertical, so a vertical shrink by a factor of what? 1/4. Exactly what you see in the problem. All right, the last transformation. They are adding 4. Again, to the whole function, f of x, or to just x. So what kind of translation is that? Well, first of all, I should have asked you what type of transformation. If they're adding or subtracting, that is a translation. And since they're adding to the entire function, it is a vertical translation. Now, this time, what direction are they moving? It's a positive, so they're going up. How many units? 4 units. And there are your 3 transformations. All right, and last but not least, letter F. Now again, be careful. F of x equals x squared. That's the parent function. That's not where the changes have been made. The changes have been made here on the g of x function. So find and highlight the parent function, which again is that little x squared. So how many things have been done to this problem? 2. You've got a 4 right here, a times 4, and a plus 1. So there are 2 transformations. All right, let's talk about the 4. What are they doing with the 4? Multiplying. So which type of transformation are we looking at? Stretch or shrink. Okay. What are they multiplying by? F of x or just x? F of x. Again, no parentheses. Okay. So f of x, which means it's vertical or horizontal? It's vertical. Kyle, when you plug it into those little equations, is 4 greater than 1 or does it fall between 0 and 1? So this is a vertical what? Stretch. Very good. If your value is greater than 1, it's a stretch. And Kyle, by a factor of what? There you go. Exactly what you see. By a factor of 4. And then we are adding 1. Which type of transformation, Xavier, adds and subtracts? Translation. Are we adding 1 to the entire f of x function or to just x? So what type? Vertical or horizontal? This is a vertical translation. What direction? Up, how many units? 1 unit. And there are your 2 transformations. And that is lesson 8.1 and 8.2.